Hello Algebra 1 and welcome to Chapter 2 Section 8. This is Proportions and Similar Figures. What we're going to do now is we're going to bring understanding of proportions to problems introducing similarity. Hey, if you go ahead and flip over, we're going to take a couple notes. We have triangle ABC, we have triangle FGH. If we're talking about similarity, we're going to use this symbol right here. This means that triangles are similar. When we say triangles are similar, what we're saying is the measures of corresponding angles are equal. For instance, this A, it goes ABC, that corresponds to FGH. So angle A is actually congruent to angle F. Angle B corresponds to angle G, and angle C corresponds to angle H. Okay, we can also say that sides are proportional. So if we have the side AB, that is proportional to FG. Okay, and then the other thing that we have to look at is the order in which we name figures is important. So if I name my one triangle ABC and it is similar to another triangle, then in this case this is going to be FGH. If I start with B and I said BCA, then I would have to name the other triangle. Hopefully you said GHF. If triangles are similar, we can also say, again, just like I said, angle A is congruent to angle F, angle B is congruent to angle G, and angle C is congruent to angle H. Or again, the corresponding sides are proportional. So proportional, we're saying that their ratios are equal. So if I said AB over FG, that should be equal to AC over FH, or that should be equal to BC over GH. Okay. Now that we have some information on similar triangles, let's go back and say, if in the diagram triangle ABC, which is similar to triangle DEF, how long is DE? So what we want to figure out is, if we go over to the right triangle, we want to figure out, well, how long is this side? So what we want to figure out is, how long is DE? Well, we have numbers. We have to figure out DE corresponds to, or is similar to, what side on the other triangle. Well, if we look back at the very beginning of the problem, we know that DE should match up with AB. So if we have AB on one triangle and put that over DE, that should be equal, or the ratio should be equal to BC over EF, or we could also do AC over DF. Okay. We only need two proportions, as we saw in the last section, so let's just stick with BC over EF, which is equal to AB over DE. And the reason why is we have 16 for BC, we have 12 for EF, we need to find DE, which is our x, so we need one more side from the ABC, and we have AB, which is 10. So if we plug the numbers into the corresponding sides, BC is 16, EF is 12, that should be equal to 10 over length DF. Okay. We now have a proportion. We need to cross multiply. Okay. So we're going to go 16 times the length of DE. That should be equal to 12 times 10. We get 16 DE, which is equal to 120. Let's divide by 16, and the length of DE should be equal to, calculate, 7.5. Let's try number 2. The sun's rays strike the building and the girl at the same angle, forming two similar triangles. How tall is the building? So we have two similar triangles noticed by the girl and the building. What we can do is we can use our similarity properties to solve for x. Okay. Well, one thing we can do is we can say, well, let's start with the girl. Let's say the girl's shadow over the building's shadow should be equal to the girl's height over the building's height. And the reason why we're using the shadow and the height is we have 3 feet for her shadow. We know the girl is 5 feet. So hopefully, we have the building is 15 feet for a shadow, so we can solve for hopefully x, which is the building's height. Okay. So let's plug in the numbers of the corresponding parts. The girl's shadow we know is 3. The building's shadow was 15 feet. That should be equal to the girl's height, which was 5 feet, over our x. Cross multiply. 3x equals 5 times 15. So 3x equals 75. Divide by 3. Divide by 3. X equals 25. Now again, don't forget, it's a word problem, so let's answer the question. How tall is the building? The building is 25 feet tall. Alright, apply properties from 1 and 2. Hit pause. Do number 3. Check back in a couple minutes. Go. Welcome back. Just setting it up so we know we're taking a scale of a map and we're trying to find the actual distance using the map to see how far apart two towns are. So if we said the map over the actual distance, so we know 1 centimeter on the map is really equal to 75 kilometers. Okay, that should be equal to, when we measure the two towns map, what's the actual distance between the two towns. So we know that we measured they were 12 centimeters apart, so we're going to solve for x down here on the bottom. Okay? If we cross multiply, what we have to do is we have to just basically take 1 times x, and that should be equal to 12 times 75, which you should have gotten 900 kilometers. So the two towns, they are 900 kilometers apart. Alright, take what you apply and apply it to the practice. Come back and see us if you have any problems. And remember, do your best, forget the rest. Bye for now.